All right, and ooh, what am I? My kids played with Snapchat. Hey, hi, Richard, and welcome to the MakeCode for Microbit show, um, where we're unveiling all the beta features. And today, talking with Richard, who's worked a lot on the debugger, and give
Hi,
us
everyone.
full run through. And Richard, if you're familiar with the Arcade Advance show, is the host of that show, one of the hosts.
Yep.
Otherwise, Richard, how about you? I think you're new on this on the Microbit channel.
Yeah, no, I mean, I've been a developer on the MakeCode team for a while now, and I'm going to be showing off the debugger today, which is one of the new features that's coming into the microbit from this new release we're doing.
And we're live on Mixer, so if you have a question, feel free to jump in and ask us whatever you want. We'll look at that. And as Richard said, this is the beta, so we're looking at makecode.microbit.org/beta. The debugger does not exist yet on the regular feature, on the regular app, but you don't have to try the beta, and it's a beta, so it might have new features and fix bugs and new bugs.
Yeah.
But please try it out and tell us what you think. All right, Richard, let's go. Debugger.
Okay. Should I start a new project?
Yeah, let's go.
All right.
See if that screen sharing works. Oh yeah.
Cool.
Debugger staff. Yeah.
All right. So we've just got a fun project here, and what do you think we should do in the project? We need something to debug, so it's got to be something that involves variables. What do you think?
We could do a counter. Kind of
Okay.
our, yeah. You know,
Sure. That's easy enough. So
clicking.
let's.
You click button A to increase your counter. All-time classic.
Yeah. Perfect. So let's go ahead and create a variable for that. We're going to call this count. And we're going to go into the input category and drag out some on button pressed blocks. We'll get two. We'll do up for A and then down for.
Sounds great.
And then inside variables, we can get this change count. Duplicate that. Change this B1 to be -1. So if we press A, it'll go up by 1. If we press B, it'll go down by 1. And then we also want to show it on the screen, probably.
Yep.
So I'll drag out the show number. And then the count. And if I duplicate that, cool. So we can try this out in the simulator real quick. If I press A, I get 1, 2, 3.
And in the past, this was pretty much the only thing we could do as far as testing our code and making sure it worked. We had to try it out in the simulator and kind of at a very high level see if it works. But in general, when we code, professional developers, we use things called debuggers. We really look at what the code is doing line by line. We're going to show that in this demo.
One of the great features of the microbit is that you can just print stuff out on the screen, but it does take a while.
Yeah, we have a log feature, so you can print stuff to a log, but still, it's not integrated in the flow as good as it should be. So hopefully, the debugger is going to be a huge help when students are trying to understand what the program is doing.
Yeah. So let's go ahead and try out the debugger now. You might have noticed this button here is different than the button that appears on non-beta.
The slug is gone.
Yeah, the snail is gone.
Sniff.
So there used to be a snail icon there, and if you press that, your program would go into slow-mo, where you'll be able to trace the execution. But we have replaced that with this bug. Don't worry, though. Slow-mo still exists. But
yeah.
you need the bug first.
Our mascot.
Yeah. All right, let's go. All right.
Yeah, and you'll notice you're in debugger mode, right? So top of the screen is orange. There's a big exit debugger mode. You're not editing code now. You're looking at your code, trying to figure out what it does. So it's really two modes that are going to happen. You're going to see with students. The code is read-only.
Yeah. So if I click any of these things, nothing's changing. I can't drag blocks around. It just drags the workspace. So.
All right. So what do we do?
Yeah. All right. So you might have noticed that on these blocks we have these little dots that have appeared. These are places where we can set a word called breakpoints. The way to think about a breakpoint is if you have a part of your program that you want to look at closer, you want to see what's happening at that part, you can set a breakpoint, and then when the program gets to that part of the code, it'll stop and let you take a look at what's going on. So the easiest way to kind of demonstrate that, I think, is to just show it. So I'm just going to go ahead and put a breakpoint right here on this show number. So you see it turns red. That means the breakpoint is activated. And now if I press this A button.
Oh, wow, cool.
Yeah.
So now the block is highlighted. And that means we're about to run this code, or we just ran it.
So that means that this code just ran, and we have stopped before this one has run. So you can see there's nothing showing up on the microbit yet.
And that's really where we're going to see the debugger being so cool, is that although we see nothing on the screen, we actually see the variable value. It's right there in the middle.
Yep. So we can see our count right here. And we see it's already 1 because we've already done that change by 1. If I were to unpause by pressing this play here and then hit it again, now you can see count is 2. So this is changing with the actual value in our program.
So we're now able to look at the kind of the live value of any variable that we have in the program. And also we can do line by line, right? So there's a few buttons on top. You've hit the play.
Yep.
The play means run until you hit another breakpoint.
Yeah, exactly. So play just means keep going, but if it does hit another breakpoint, it will stop again.
And there's also step. So step is, now maybe you should add a few more blocks so we can see what step does.
So in order to show off the other things, I'm going to have to make this program a little more complicated. So I'm going to go ahead and get out of debug mode real quick.
Yeah, you can get out of debug mode by pressing either the icon or the big exit button.
Yeah. Okay. So what's a fun little thing we can do? How about we do something with logic? That's always fun to trace through.
Yeah. So if it's even or odd, you can do something different.
Oh yeah, that's perfect.
Yeah.
So there's an easy way to test if something is even or odd in programming. We use this remainder block, this one right here. And this is just like the remainder that you've used in math class if you've done long division before. So this would say if I were to divide 0 by 1, what would the remainder be? In this case, it would be 0. Let's go ahead and make this a little more complicated.
Yeah, I think we can get rid of this on start if we want and bring it.
Oh yeah, that's a good idea. Here it forever too. Sometimes these programs get a little cramped.
Good idea to clean up your code. Ultimately, you pay a price for all these little blocks lying around.
Yeah. Okay, so I'm going to take out my count variable and I'll put it in the first argument, and we're going to divide the count by 2. And so there's 2 possible remainders if you're dividing by 2. There's either 0 or 1. If it's 0, that means it divided cleanly, so it's even. That means it is divisible by 2. Or if it's odd, if it's 1, that means that it's going to, do that.
Yeah, we can use, I think we can do show icon and use a checkerboard, maybe to alternate design. Could look good.
Oh yeah, let's do that.
Yeah.
So we can go into show icon. I'm going to say we like even numbers, so I'm going to leave that as a heart. But for odd numbers, we'll do this angry face.
Angry face, all right.
All right, so let's go ahead and go back into debug mode and try this out. If I press the A button now, you can see the count is 1, so I get an angry odd face.
It's hard to tell because we don't see it. But again, the debugger will help us figure that out.
Yeah. So before I hit this A button again, let's go ahead and set a breakpoint. And I'll set it right here. So this means that we're going to stop on this block before this is executed, but after this is executed. Cool. Yep. All right, so now we're paused on this if statement. We can figure out which of these 2 branches we're going to go into by using that step thing that Pelly mentioned before.
And step is go to the, run the current line and go into the next line. If you're familiar with debuggers, this is a step into. We'll go also inside of functions, things like that. But for all matters, if you're teaching the debugger or you're new to that, this is really just taking one step, the program
Yep.
execution.
So if we look at our program right now, we can see count is 2. So the remainder of 2 divided by 2 is 0. So it should go into here, but we can press this step and we'll see what happens.
Yeah.
And yeah, there you go.
Works like expected. Debugged.
Yeah. And if I step again, nothing is highlighted because we've now the program waiting.
Yeah. And so I see the snail is back. So it'd be cool to show how the snail now works with the debugger.
Yeah, totally. Let's try that out. So I'm going to turn off this breakpoint, and I'm going to click the snail, and that'll turn on slow-mo mode again. And so you can see our stuff's already getting highlighted, just like it was before in slow-mo. But the thing that's different now, and the thing that makes it a whole lot more useful, is you can see our variable over here, count, is actually shown, and it says 0. And if I were to press some buttons here, so if I were to press A, you can see my program is getting highlighted again. It went to here, then it went to here. My count went up by 1, and I can see what the value of the variable is.
So this is very interesting. This is our exactly our slow-mo as before. We run a step kind of every second, but now you can also see variables in the variable view. So debugger mode is going to be extremely important. Extremely useful to debug your problem. There's a few tips we can give you. For example, use variables to see values. So in this program, maybe I'm not sure about the math that's going on in the in this if statement. So what I can do is I can actually create a new variable, compute the value and store in that variable, and then use that variable. And that will mean that the debugger will show me what's going on here. So I think Richard will do that. We're going to say, we're going to call it is even. Something like that. Yeah.
Sure.
And how about we zoom in, maybe zoom back in a bit?
Yeah.
All right.
All right, I'm looking at it in like a Teams view, so it's hard to tell how big the screen is.
This is a good tip for you if you're starting with debugger and you're trying to figure out values. Just use variables. Put values into variables because they will show up in the debugger. You can put booleans in variables too. And then you're going to end up with a lot of variables.
Yeah. We've made this, it's the same as before, but now we have this is even variable. And if we go into debug mode again, we should be able to see that go. So it starts out as false. All Booleans started as false. And if I press A,
sweet,
it's false because it was 1. And now if we press it again, now it's true, which is great.
So there's a few things we did. And then there is a restart button. You can pause the program. So there's kind of the basics here. We've added some tracing of sensors in MakeCode. So if you use, for example, the accelerometer, it will show up in the variable view automatically. So you don't have to add that. But
really, I did not know that. That's
I went to town on this. There's some environment values that are kind of built in. So any sensor data will show up kind of magically in your variable view. If Richard, you had a for loop that reads the accelerometer, we should see that.
Yeah, let's go ahead and do that real quick. So again, exit debug mode so I can make changes. I'll go ahead and drag out like a forever loop.
Yeah.
And we'll just do, we'll drag out the acceleration when we zoom back in again. And we'll just call, how about show number?
Yeah, let's mess it up.
Yeah, all right, cool. So now we can already see on the simulator, we have my AX value, and it's printing out. Let's go into debug mode though and see what Pele was talking about. So if I press slow-mo.
Oh, what's going on? Okay, I take that back. Yeah, this is a beta. Something is going on.
Yeah.
Yeah, it should have read. It's reading the accelerometer. Somehow it's not. Well, maybe it's because it's 0. Oh well.
Yeah, we've
But
got some bugs.
it will come in the release. This is going to be interesting. So you can see also the values that come from the system and see them there, although we show them in the simulator. Hey Richard, how about we jump to JavaScript now, or
Oh
even
yeah, totally.
Python, and talk about the debugger in text mode?
So let's go ahead and do that. Let's go switch to JavaScript. So we got the same program as before. Let me space things out a little bit.
Let's remove the acceleration because I'm messing
Oh yeah.
more. So we're now in JavaScript. You can see there's curly braces. You can see on top the language.
Yep.
Yeah.
All right, so let's go ahead and turn the debugger on, and we'll see something pretty similar to before, but a little bit different. So now we have different options over here that you can see. We have pause and then 3 different kinds of step, and I'll go into those in a second. But then we have the same slow-mo and refresh. We also have this call stack section, which again is going to make a little bit more sense once we actually put in some functions or something.
Yeah, so the high-level message, you're getting closer to like using a real full debugger when you're doing text, and some features that are more advanced are just available there.
Yep. Yeah. But the basic workflow is the same for JavaScript as it is in blocks. So if I go over here, if I hover on the left, you can see where I have all these locations where I can set breakpoints. And so I'll set this one right here. And now, if I press A, it should not hit because I chose the wrong part.
But now it hits.
Good time.
But you could remove the. Oh yeah, no, slow-mo is good. Yeah, it hits it and it stops, and we're back to. We can see the variables, and now we have call stack.
Yeah, now we have this call stack, which isn't very interesting.
Yeah,
it just says inline, which is because we're inside a function that we just declared here. We didn't give it a name.
How about we move that function out into and give it a name, then we'll see that.
So I'm actually going to do 2 things. I'm going to give it a name, and I'm going to give it an argument, and that'll be fun. So let's go ahead, and I'm going to create a new signature for this function.
Yeah, so you have to exit debug mode. Because you have to. So we're writing a function here.
Yeah, so I'm going to call this update count, and it's going to take in 1 parameter, and that is going to be the count, which I'm not calling count because we already have a variable called count. I'm going to show something off with this real quick. And let me go ahead and just take all of this stuff and put it in here. I'm going to leave count up here. Oh, whoops, I did a
mishap.
I guess when you're remote controlling a Windows machine, you need to do Control X.
You're doing great. You're coding better than me. All right.
Okay, and I'm going to call this update count.
The count. Count. Yeah, it takes count.
Pass and count. And then let me change these ones in here. Or again, got to do control.
You just have to change in one spot.
Yeah.
Yeah.
All right, let's run this again.
I'm making sure it still works. Yeah, it looks like it's working, but maybe it's broken. We'll see in the debugger.
Yeah. We'll try it out. Okay, so now I'm going to set my breakpoint to be right here. And I'll go ahead and hit it by pressing A. And so let's talk about these 3 different kinds of step. So we have 3 here. This is step over, step into, and step out. And like we talked about in the block debugger, the block one is step in by default. And step ins are really useful if you just need to get to whatever is going to be happening next. But in layman's terms, what it does is if you have a function call and you call step in, it will go inside of the function. Step over will instead go over the function, and step out will go out of whatever function you're in to the next line in the function above where you are. I hope that was somewhat coherent.
Yeah, this is best learned through practice, through exercise. A bit abstract right now.
Yeah.
Um,
But
yeah, the block in blocks you always use step into, so that's the one you're used to. But sometimes as you just want to skip a whole function, there's too much code.
yeah.
Yeah.
So let's show that off real quick. If I click step over, I'm now on this update count line. The next thing that's going to execute is this is even down here. But if I press step over again, I'm not going to get there because I stepped over this call.
Yeah. That's very helpful when you're trying to get somewhere and you don't want to be sidetracked into different functions.
Yeah.
You're going to do step over. Yeah.
Mm.
All right, let's try step into.
All right. So yeah. I've hit the breakpoint again. I'm going to step into now. And so now I'm on the update count line. If I press step into again, now we are inside the function. So yeah, it works just like you think. And let's go ahead and talk about these other things here while we're here.
Yeah, we can see the count. I see that there's a call stack now has update count in it. Things changed.
Yeah. So we can see the count, which we couldn't see when we were outside the function, and that's because this is a parameter to this function. It's a local variable.
It only exists while you're in that function.
Exactly.
It doesn't exist when you're in the main or... Okay. So you'll see values that are within the scope, what we call the scope of your code.
Yep.
Cool. So yeah, so just to mention that in blocks, all the variables are global. That means you can always access them anywhere, mostly, with some exceptions. But in TypeScript or Python, you're going to be able to create variables that only live within a certain area of the code.
Right. Yeah. So I have the count here, but if I were to put it here, that would be an error.
Yeah. Because
I'm outside of this function. Okay, so the other thing that kind of happened when we went in here is that now we have this call stack and we have this update count and inline. And this is really useful for figuring out if you hit a breakpoint inside a function, it's usually you want to know who was calling it. Like, how did you get to this part in the code? And what sequence of events led you here? And the call stack's really nice because now I can click on this inline and it's going to take me up to the line that called this function.
And we can see the arrow, the black arrow on the left of midline change. It tells you which frame you're looking at. And also all the variables change. So you also see the values of the variables for that step in your call stack.
Yeah. So I'm in this inline function, so I no longer can see the count because the count is only inside of here. So it's disappeared from my variables.
But it's still there, but you have to click on the call stack to see it.
Yeah, exactly.
Yeah. All right, and this is, for whoever is novel to Debugger, this might throw you a bit, but with practice, this is going to be very handy tool. This is very similar to debuggers you'll find in Chrome and Visual Studio and all professional tools. So the skills and the affinity to this concept, you'll be able to port that directly into what the pros are doing.
Yeah.
Yeah.
I know when I started debugging, when I started programming, I was always like, the debugger is cool, but it's so complicated, it's difficult to learn. I'm just going to print everything out. And it took me a while before I realized that the debugger makes your life so much easier.
Yeah, we're going to be using extensively the debugger in future videos to also teach it on the fly, but this is going to be your best friend. Guarantee it.
Yep.
Okay, cool. So we've got so the call stack, we've got variables changing. We saw, and then there's the step out, which is the last one we haven't covered.
So if I were to take another step here, so if I do a step over, you see I'll end up on this next line. And the next line that's going to run is either this show icon or this show icon. Actually, I can figure it out. Is even is true. So it's going to be this one. But if I click step out, what's going to happen is I'm not going to pause there. It's just going to go out to the next line after this function call. So there is no next line, so it's just going to keep running. But let's try that out real quick. I'll go ahead and click step out.
And we're done.
Yep, now the code's back to running. It's waiting for me to press a button. That code still ran. We just didn't see it happen. You can see that there still is a heart icon that's being shown. We just didn't pause for it.
And how about we show it in Python, just for kicks, and then
Yeah.
I think this is a pretty good deep dive on what's coming up with the debugger. It's quite an important feature. All right, so we're in Python now. MakeCode Python. No more curlies.
Yep. Once again, let me format this a little bit, just because it makes it easier for me to read. All right. So we've got the same code as before. Our on button pressed A is up here. Our on button pressed B is down here. And then we have our update count. So let's go ahead and go into debugger mode.
And we can set breakpoint just like in TypeScript by clicking on the gutter there.
Yep.
All right.
Let me go ahead and hit that breakpoint. You can see we're paused. I guess it's only highlighting the plus equals 1, but sure.
We'll take it.
Yeah. And
we see the variables, we see the call stack. Now we have actually a name because we have to name them in Python. So we see we're on button press A.
Yep.
So
Python does have inline functions, but most of the time we don't convert using them. We convert using
they're lambdas, so they need to return a value. Yeah. Anyway, geek talk. In Python, we name our functions of names.
Yep. So if I do the same thing as before, I can step over, step into this function, and step out of it. And it works just like the JavaScript debugger. You can see the call stack and all the different points. Let me show that real quick. So I'll go back to where I was, and I'll step into the update count. And you can see where we have update count right here. We have unbutton pressed A right here. And just like before, you can see the count inside of update count. But if I go to the above one, you can't see it anymore.
Yeah, this is great. So same experience. So to recap, we've got a new tool in the debugger, and you can access it via this bug icon. Find under the simulator, it's our debugger. It's got a nice simplified version in blocks, and then we've got some more features in text. And hopefully the debugger will help you figure out what's going on in your programs. Use a lot of variables, and you'll be able to see a lot of the state of your program. I think that's it. Richard, anything else you want to add?
Well, the only thing I mentioned is we kind of glossed over it, but the slow-mo is also available in text mode. So if you click that, it'll highlight your code just like it does in blocks. I think we showed that off a little bit when we first switched over, but yeah, that's it.
If we got one of our power user, MakeCode, who's using the debugger too and liking it, so go ahead and try it out. This is really going to help you when you're confused by why things are not working properly. All right, and I think this is the end for the show. Richard's the first time I'm hosting you, but this worked pretty well. It was a lot of fun to be together.
Yeah, thanks for having me on and dealing with all of the streaming part of things.
Yeah, that's cool. That's cool. Well, talk to you later since we got to work together. All right, thank you, Richard, and see you in a future episode where we go and drill down into the MakeCode for microbit beta and all the new cool features that are coming in this summer.
Yep, cool.